Genetics. It's a topic that many find a bit boorish, but for the minority such as myself, it's an extremely interesting subject. It can unravel some of the most intriguing secrets that before DNA research, people didn't even think was possible. It's the study of heredity and how traits have been passed down through inheritance. Genetics ranges from research through plants and animals all the way to us humans. But for today, we'll be talking more about human genetics, more specifically how we as humans can use our genetics to trace how our ancestors gave their traits to us, as well as how our ancestors gained those traits through migration and interactions with their environment. Take for example, excuse me, can you tell me where you're from?
Down the street. Italy.
And with this we have the question of how genetic traits have evolved over time using genetic migration of peoples. And luckily, we have the answer. Through the migrations of peoples, genetics has evolved due to reasons such as waves of different settlements causing a unique genetic portfolio, geographic isolationism causing a lack of variance between individuals, and mutations triggered by one's surroundings. Migration is an extremely important factor when it comes to one's genetics. In the documentary, The Journey of Man, A Genetic Odyssey, geneticist and host Spencer Wells solves the age-old enigma of how the first humans out of Africa migrated to the continent of Australia. As we all know, humans, or Homo sapiens, migrated out of Africa and spread to the rest of the world. But researchers and scientists have always wondered how Africans migrated out of Africa and into Australia, and what their route of passage was. Spencer Wells did this by coming up with a theory alongside Indian researchers on how those who migrated out of Africa to Australia migrated in a coastal pattern from East Africa to northern Australia. In order to test his theory, he set up an investigation in a rural town in India where those early humans may have settled, to see if any of the civilians held the key to proving his theory. Spencer Wells only used male participants because of their Y chromosome. Y chromosomes are only passed down from father to son and are perfect when studying migration. After the fact, one singular Indian man held the trait that was necessary to prove the theory. This meant that the coastal theory of humans migrating out of Africa to Australia could possibly be true. Now that we've established how genetics can help us find the paths of people migrating out of Africa, we can focus on how migration has caused certain groups to have unique genetic patterns. And with this, we can look at the book Blood of the Isles by Brian Sykes. Through his research, Brian Sykes used similar methods as to Spencer Wells in the documentary in order to gain information on how certain groups in the European Isles, specifically consisting of England, Scotland, Ireland, and Wales, have differentiating genetic patterns in their ethnic groups. Brian Sykes uses the method of the inheritance of the Y chromosome that's only passed down by males and the inheritance of the mitochondrial DNA that's only passed down by females in order to find how the people of the European Isles gained their traits through migration. With his research, Brian Sykes found 7 significant mitochondrial DNA patterns that went back thousands of years in Europe. And with this, he gave each a specific name, consisting of Helena, Tara, Jasmine, Zena, Velda, Ursula, and Katrine. The same goes for men with only 5 paternal grandfathers. This included Oisin, Wodan, Sigurd, Eshu, and Ray. Brian Sykes first explained the correlations he found when researching the country of Ireland. There he found that a staggering 10% of all Irish people, both men and women, have the same mitochondrial DNA sequences as to Ursula. This meant that those who were related to Ursula, their ancestors, arrived in Ireland at around 7,500 years ago. When looking at Y chromosomes, almost 80% of all Irish men were part of the clan of O'Sheen. The farther west, the more and higher percentage of people were directly descendant of the clan of O'Sheen. This is probably because of many invading sources in the east, which gave more genetic variation. The clan of O'Sheen has been dated back to entering Ireland at around 4,200 years ago.
You may or may not be wondering, what are genetics like in places that are so extremely isolated that interactions can only be between one and another? This can be seen in the island of Tristan da Cunha.
Tristan da Cunha is an extremely isolated island off the coast of southern Africa. It has a unique genetic history due to the lack of migration to the island. It was first settled in the 1800s by a Scottish corporal, his wife, his kids, and 2 soldiers. The additional settlers were only of people who were from shipwrecks or women who were brought over from the neighboring island of St. Helena in order to be those who were shipwrecked wives. These people are accredited to being the descendants of all 200 people on the island. Due to their isolation, there is an extreme lack of genetic variation. This shows that migration or the lack of migration largely affects the genetic makeup of these people.
Similar to the island of Tristan da Cunha, where the people were affected by the geographical location, genetic sequences and mutations can also be affected by social and environmental factors. In the podcast Out of Africa, Uncovering History and Diversity of the Human Genome, geneticist Sarah Tishkoff explains how she found an interesting genetic connection of the Ari people in present-day Ethiopia to their occupation.
The Ari people have an almost caste system society influenced by the occupation one has. The University College of London found that those who had the same occupation have closer genetic ties than to those of a different occupation. Due to their society, their genetics has been affected.
Geneticist Garrett Hellenthal also found a unique genetic mutation in Kenyan pastoralists.
Kenyan pastoralists are a famous group of people who are known for first domesticating cattle. Due to this, they gained a trait similar to most Europeans, which is the ability to consume milk, or being lactose tolerant. Due to their environment and their society of cattle domestication, these pastoralists gained the trait of being able to consume milk. All in all, the migrations of people, their habits, and their environments play a large part in what makes our genetics up today. Thank you so much for watching, and I hope you're just even a little bit more curious on what makes you, you.